what is the middlemost term, or what is such a term around which the whole data is concentrated. That's the meaning of central tendency, right? So I'll repeat once again, the values around which most of the data is accumulated, right? That values are known as central tendency. Now there are three measures of central tendency. We will see one by one. The first one is mean, then we have median and mode. So we will see all these three measures of central tendency one by one. First of all, the thing which you need to understand is that we never write mean. Okay, when we write this mean, we have to write arithmetic mean, because there are three types of mean which we will discuss right now only. We have three types of mean, but in statistics the most commonly used is arithmetic mean. I will show you how. So in the first part of measures of central tendency, we are going to discuss the mean. So let's understand what is this arithmetic mean. Arithmetic mean. So some of you might be aware of this term, arithmetic mean. It is actually the weighted average of all the observations. Now what do I mean by the weighted average, or let's say the average only? We mean by that is that when we take the sum of all the observations, sum of all the terms, and take the ratio of the sum of all these terms with number of all terms, then we will get the average of this whole data. Okay, let's suppose I have 2, 3, 3, 4. So I have 4 terms which are 2, 3, 3 and 4. Now I want to see what is the average of this data. Now mean is the other word for average only. If we want to see what is the average of this data, what we will do is, we'll take sum of all these 4 terms. We'll take sum of all these 4 terms and we will divide this by the number of terms, which is 4 over here. So this will give us 12 divided by 4 is equal to 3. So the mean for this data, or the average for this data, will come out as 3. So that's how we calculate the arithmetic mean. So let's write down the official definition for this arithmetic mean. This is equal to arithmetic mean of a set of observations is equal to the ratio of sum of observations and the number of observations. So if we divide the sum of all the observations by the number of all the observations, we will get the arithmetic mean. So let's see how this works. Now we've already discussed that there are 2 types of data when it comes to grouping. The first one is raw data and the second one is group data. Raw data can also be known as, this is also known as, or it can also be called as ungrouped data. So when the data is not organized, it will be coming under the raw data or the ungrouped data. So let's see what is the procedure of finding arithmetic mean in both the cases. So first of all, we will discuss the raw data. Now for the raw data, it is pretty much simple. If you are given the data like this, 1, 2, 1, 3, 4, 5, 6 and so on, let's say 7. Last term is 7. And let's suppose I have 100 such terms. So I have 100 terms varying from, let's say, 1 to 10. So this is the range is equal to, let's say, 9. Upper limit minus lower limit. This already we have covered. This will be the range. Upper limit here is, which one? 10. And the lowermost frequency is 1. So highest value minus the lowest value. Upper limit of the value minus the lower limit of the value will give you the range. So range here is equal to 9. Now let's see guys, can you tell me what is the most probable value of mean here? What is the most probable value of mean? So if I give you 4 options, like the first option is 3, then I have 7, 5, let's suppose, then I have 8, then I have 1. So can you tell me what is the most probable value? Now the most probable value could be 5 only, because you can see that this is easily scattered. Now this data is scattered. What do we mean by scattered? That we have the values which will be higher also, the values which will be lower also. So the middlemost value will be most likely the mean, right? But we cannot verify until and unless we find the exact numerical value. And this value of mean can never be greater than the highest value and smaller than the lowest value. So it has to lie between the lowest and the greatest value of frequency, right? So let's see. Now let's write down the formula, numerical formula, x bar. This is how we denote the mean. So x bar is equal to sigma. So first of all I am going to write for raw data only, sigma xi divided by n, where xi is the ith observation. Xi is the ith observation and n is the total number of observations. So from here you can see that mean is equal to sigma xi upon n, right? So if we take, let's say, 4 numbers, 5, 6, 7 and 8. So the mean here will be equal to 5 plus 6 plus 7 plus 8 divided by 4. Now xi, let's see what is the meaning of xi. If I write the value of I is equal to 1, I will get the first term or the first observation, right? So x1 will give me the first observation, which is 5 over here. x2 will give me the second observation, which is 6. x3 is third observation, which is 7. x4 is fourth observation, which is 8. So these are the 4 observations, and this is how we write the general term for the observation, xi. So this is the ith observation. If the value of I is 3, so that means the third observation, right? So this is a basic formula. Now let's do a question, a pretty easy one. Guys, tell me, what is the mean of first n natural numbers? What is the mean of first n natural numbers? Just try this one out. So what is the basic thing you need to find the mean of first n natural numbers? We know that the mean is equal to the ratio of the sum and the number of the terms, right? So first of all we'll find the sum of n natural numbers. First of all we'll find out the sum of n natural numbers, and you can see that 1 plus 2 plus 3 plus 4, this is equal to the sum of n natural numbers, which is further equal to n into n plus 1 by 2. You must remember this result from the special series, right? This is the sum of first n natural numbers, okay? And we also have the sum of squares of first n natural numbers, and that sum is given by the formula n into n plus 1 into 2n plus 1 divided by 6. So this is the formula for sum of squares of first n natural numbers. But here we need only this one. We need only this part. So sum of first n natural numbers is n into n plus 1 by 2. Now let's see what is the mean here. So mean will be equal to sum divided by number of observations, which is n over here, which is equal to n into n plus 1 by 2 divided by n. So this gives us n plus 1 by 2. So this is a very important result also. This can also come as a question that find the arithmetic mean of first 100 natural numbers. So instead of calculating the whole sum by applying the formula of AP also, or by applying the special series, you can simply remember this result, that if the value of n is equal to 100, if you have to calculate the mean of first 100 natural numbers, this will be equal to 100 plus 1 divided by 2, which is equal to 50.5, 101 by 2, right? So that's how we look into these things. We calculate the mean of first n natural numbers, and since you can see that this is a raw data, so you don't have to move into group data or anything. You can simply apply the formula sum of n natural numbers and divide this by total number of turns. Now let's see